Okay, welcome back to EO166. Today we're going to talk about the silo program a little bit. Give you guys maybe a couple of pointers that have maybe struggling with a couple of things. First piece that I want to share is the start and stop the conveyor. Of course, would be pretty simple. That would be just a sealant circuit, right, to start and stop that. So that would be, I would say, pretty straightforward. So that's you've got the normally open and normally closed push button, and you got a motor starter here. So me personally, I would probably set up an internal bit that would do the sealant circuit, and then set up the output at the bottom. But this is a fairly basic program, so if you use the outputs, just make sure they're in sequence. Remember, sequence is a big deal. We're working on programming techniques here and next level of being able to program. So we're not just throwing a bunch of garbage up on the screen here. We're making it in a nice, neat, organized manner. So that's pretty straightforward. So let's just get. I'm going to just do something real simple here. Delete this here. I'm going to just say. If I download this, I believe I can just run the order. So this is not something that you guys will be doing. I'm just doing this to get the motor running. So I don't want to give away all my secrets here. So as you can see now, the motor is running. So of course, you'd have to have a sealant circuit with this to get this to work properly. But I don't really care. I just want the motor to run. So the next piece of this I want to share is what do we got going on here? You'll see that the switch here, this proc sensor down here, I13, is the proc switch used to indicate when the box is in position. Now, one of the challenges that you'll have in industry and pretty much programming any place is an understanding of when to start a process and when to stop a process, right? So here we want to just make sure that when we start a process, it doesn't interfere with the stopping of the process or the next phase that has to take place. So what I would recommend doing here, I don't, without giving away all my secrets, I would seriously consider using this one shot, using this sensor as a one shot, excuse me. Let's go here. Dun, dun. Let's throw that in there. Over here, got one shot rising. Here I'm going to use a B314. Remember, I use the word 4 for my one shots, so I don't overwrite that word. If I ever use a B3 word 4 bit 0, I know it's supposed to be a one shot. If it doesn't end up as a one, if it ends up anyplace else, then I know I got a problem. So I can't use that address anyplace else, right? So let's see here. I'm going to say, let's just go. Let's just throw B. B3 should go on 0/0. Okay. So now I got a bit that says every time that the leading edge of that box gets to this location, it triggers this bit, right? Now, why is that important to me? That means what? I want that box to stop every time I see that come on, right? So how am I going to do that? I'm going to make that part of the stop circuit. Would you guys agree with that? So let's say, for instance, I throw in a couple of ideas here, just a couple. Something like this. I come in here, I say, yeah, let's just grab the start button here. I don't know if I grab that address or not. Yeah, there we go. All right. And why don't I just grab an address like this? I'll grab the one light just for fun. This is not what the project's requiring, but I'm just giving you guys an example of how you can use this one shot. So this is the start button. PP is part present. One shot. And this is my PP part present. PE. PRS. Prox sensor. And this is what my motor. So what I'm just going to happen here is we're going to get this light to turn. I'm going to turn this light on, and every time that prox sensor gets triggered, it's going to turn it off. Let's see how that works. Okay, so let's go to run mode. Okay, so now we're watching this trigger, right? So if I trigger this one start button, this is going to turn this sealant circuit on. Every time it passes by this guy, it's going to turn it off. Watch this. So this will give you a pretty good idea on how to stop that box, right? Every time it hits that sensor, right? So I want you to think about this circuit when you're developing your program to stop the box, because what you got to stop that box as soon as that sensor comes on. So if there was a problem, say, where that sensor was too close or too far away, what could we do? We could put even a time delay in there if we had to. But I think if I remember right, this program's set up pretty well. So if as soon as that sensor comes on, that box needs to stop, and that motor stops right on the same spot every time. So we're in pretty good shape there. Next piece out of this I want to share that can be a little bit challenging is that there's a requirement to start and stop the filling of the box. Okay, you got to be able to hit the stop button and stop the process of filling. Okay. Well, we base the fill not off of volume or weight or anything like that. It's based off time. So if you have to set up a value of time, wouldn't you think what time value or timer style would you have to use that allow you to accumulate time and not lose time every time you remove it? Okay, I want you to think really hard about all the different timers we talked about. In this particular case, we're looking at if you go to timers and counters, what kind of timers would we have? We have the timer on, the timer off, the retentive timer. What type of timer do you think we have to use? In this particular case, I would recommend using the retentive timer. Retentive timer is going to give us the ability to turn on and off this valve so we get a flow, or it's going to monitor the amount of time that the valve is open. All right. So for this particular application, I would probably do something like this. I would go here. I'm going to just say, how about the start button again? I hit the start button. Let's see here. I don't want to do this. I want the start button to turn on an output. And I want that output on for some period of time, right? The output's got to be, this is the valve here. Okay. So when I hit the start button, I want the valve to open up, right? So when that valve is open, I need to make sure that it's open for some preset amount of time, right? Would you guys agree with that? So it's got to be on for some time in order to evaluate or to get the right amount of product in the box. So in order to do that, what do we have to do? We have to monitor the amount of time that is open. So we could do something like this to monitor that. We'd come in here and look at the valve itself. Come here, look at the retentive timer. Oh, put it in the wrong spot. You have to call this a T4. Preset value of, say, for 5 seconds. So now let's just evaluate how this works. So I'm going to hit this start button. You're going to see it time. So I'm hitting the start button. We're turning on the valve. The valve is coming on, and as you can see, it's timing. And you can imagine what would happen when I hit the value of 50. What do I want to have happen? I want that done bit to turn on. And, you know, as you can see, it's a value of 50. It's done. So what do I got to have happen at that point? I got to turn off the valve. And I got to start the conveyor moving that product again. Well, I think I got to turn the full light on for 1 second. Then I got to start the box moving again. So here's a few pieces of the puzzle I'm giving away for you guys. So have a good time with this one. It's not super hard, but it's fun and challenging. So wish the very best for you. We'll be talking to you soon.